Number 13, what is the domain? It means who can X be? Could I plug in 5 here and get an answer? The answer is yes. Could I plug in 10 and get an answer? Yes. There's a bunch of numbers we can plug in, but there's somebody that's going to give us trouble. When you and I have a fraction, we should know that everybody's going to work, except you can't let the bottom of a fraction come out to be 0. The denominator cannot be 0. So we say, hey, that x plus 3 can't be a 0. What's going to create that? Well, if we solve for x, we'll see that would get created when x is -3. So we say, hey, x can't be -3. So the final solution here is we say, hey, the domain, the piece of people who could work, the numbers that could work, are all real numbers, except x cannot be a -3 because -3 will mess it up. What about the domain of a square root, of a radical? Well, there you need to be positive. So these, we always say, hey, you need to stay bigger than or equal to 0. As long as you're bigger than or equal to 0, we're going to get a solution. That means basically we're saying, hey, you need to stay positive because I can't take the square root of a negative number. So now I solve this. I subtract 4, and I have my answer. X has to be bigger than or equal to -4. The way we write the answer, we say all real numbers such that x is bigger than or equal to -4. -3 works, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.1, 9.2. All those work. Those are the domain. The domain, we're saying who works. If it is not a square root nor a fraction, it's going to be all real numbers. Don't get tricked. These are the only two that sort of have restrictions for the ones we're working with.